Hey everybody, and welcome to McCardle Math Academy. In this video we're going to be talking about improper integrals, and specifically we will be doing one example. So the example we're going to talk about today is the integral from 0 to infinity of e to the x over 1 plus e to the x. So when you get an improper integral, the first thing you want to do is identify all the different problems that you see, either with the limits of integration or with the continuity of the function of the integrand. In this case there's only one problem, and that's this infinity. Alright, so this is a problem that we have because our previous techniques before we learned about improper integrals don't cover this situation. So what we're going to do is we're going to get rid of that infinity and replace it by a b. So now we have a definite integral from 0 to some constant b of the same integrand. And to account for the infinity, we introduce a limit as our constant b goes to infinity. So what we'll do is on the inside we'll find out what this integral is just with our normal techniques, and then we'll take a limit as b goes to infinity. Alright, so let's take this definite integral over to the side here. So we're going to find that integral with our previous techniques. So we notice that the best way to solve this integral would be to introduce w to be introduce a substitution of 1 plus e to the x and dw dx. When we take a derivative is just e to the x. So we solve this for dx, so we find that dx is dw over e to the x. Alright, so here's the important pieces for my substitution, and I make this into the original integral. So we have the integral now from star to star of e to the x over w times dw over e to the x. Again, notice the bounds. I have to just put these little placeholders in because we're changing variables to w. So now you just have the integral of 1 over w dw, and so that you take that integral, you'll get ln of w, and again these are from star to star, so that's from star to star. You go back to x's, so we get 1 plus e to the x from 0 to b. Alright, and finally the last step, we're going to need to go outside the box here, is to apply the fundamental theorem of calculus. So you get ln of 1 plus e to the b minus ln of 1 plus e to the 0. We know e to the 0 is 1, so this becomes ln of 1 plus e to the b minus ln of 2. So this is what we're going to take back up here to our limit. So let me zoom out for a second so we can see. We did this work on the side to find out what that definite integral was. This is what we ended up with, and we bring that back to our limit. Alright, and now we have to just take a limit. So we look at this expression, the limit as b goes to infinity of these two pieces. We notice that this is just a constant, so we can pull that out of the limit. And once we pull that out of the limit, it's easier for us to see what this does. And we notice that if we were to plug infinity in a sense, e to the infinity is infinity, and ln of infinity would also be infinity. So this whole limit goes to infinity, and then you're just subtracting a constant value, which means that the original integral that we started with must diverge. So our conclusion is that this improper integral diverges. Alright, hopefully this explanation helps, guys. Let's zoom out so we can see the whole picture. You take your improper integral, you add in a limit here to get rid of the problem of infinity. You then take the definite integral off to the side, do that in your normal fashion, bring the result back, and then just calculate a normal limit as we always would. Alright, thanks guys, and I'll see you next time.